Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is the lesson on completing the square from section 3.3. Let's get right to it. So our goals for today is to use the principle of square roots to solve by either extracting square roots or completing the square. What is the principle of square roots? Well, if x squared is equal to k, then x is either equal to the square root of k or x is equal to the negative square root of k. And so essentially, whenever you take the square root of both sides of a function, you have to consider both the positive and the negative values. And so how can we use that to solve? Well, let's start with this one right here, where I am just on this one going to take the square root of both sides. And when I do that, I have to include both the positive and the negative in that square root of 9. And so in that case, since 9 is a perfect square, this solution is both positive and negative 3, because positive 3 squared is 9 and negative 3 times negative 3 is also positive 9. So that is my solution. For the second one, I have a little bit more work. So the first thing I'm going to do here is add 75 to both sides. Yeah. And that'll give me 3x squared is equal to 75. And then I'm going to divide by 3. And that'll give me x squared equals to 25. And take the square root. And since I'm taking the square root, I'll get x squared equals plus or minus the square root of 25. And since 25 is a perfect square, my final answer, x equals plus or minus 5. And again, the thing that costs most of my students points is they forget whenever you take the square root of both sides to add that plus or minus in there. Completing the square is a method that you can use to solve a quadratic equation that is in the form ax squared plus bx plus c. And the way that you're going to do that is you're going to move the constant to the right hand side, so we'll subtract c from both sides. Then if a is not equal to 1, we're going to divide both sides by a, and then we're going to add b over 2 squared to both sides of the equation. That is actually completing the square for us. And then we'll have a perfect square binomial on the, well, in this case, we'll have it on the left-hand side. And then we will solve for x by using the principle of square roots. We'll take the square root of both sides, we'll do our plus or minus, and we'll get our solution. So, just some examples, and I have 2 of them here. One where a is equal to 1, and one where a is not equal to 1. So I want to use completing the square to solve the following quadratic equation. So following this set of steps, we're going to move the constant to the right. So here I'm going to subtract 2 from both sides. And we're going to say from both sides from now on, so it's just subtract 2. So we'll go x squared minus 3x is equal to negative 2 here. Oops, negative. Come on, give me my tool back. Negative 2. And then since a is equal to 1, we can skip that step. We're going to add b over 2 squared to both sides of the equation. So here we're going to add b is negative 3, add negative 3 over 2 squared to both sides. That'll give me x squared minus 3x plus negative 3 over 2 squared, come on, squared, and then negative 2 plus negative 3 over 2 squared. And now this is a perfect square. All right, and the easiest way that I can think of is I just taken that x, I'm taking that 3 over 2, and I'm rewriting it as x minus 3 over 2 quantity squared. And then let's simplify here. So negative 3 over 2 squared. So negative 3 times negative 3 is positive 9. 2 times 2 is 4. Negative 2, I need to make fourths. So how many fourths are in negative 2? Well, there are negative 8 fourths in negative 2. And so when I combine these together, I'll get on this side x minus 3 over 2 quantity squared equal to negative 8 over 4 plus 9 over 4 is 1 over 4. And so here I'm going to take the square root, and the square root of x minus 3 over 2 squared is just x minus 3 over 2. And then I'll have plus or minus the square root of 1 over 4. And so the square root of 1 over 4, well, both 1 and 4 are perfect squares. So I get plus or minus 1 over 2. The square root of 1 is 1. The square root of 4 is 2. And I have negative 3, come on, negative 3 over 2 there. And so I'm going to add 3 over 2. And so I've got x equals 3 over 2 plus or minus 1 over 2. So here I have both 3 over 2 plus a half and 3 over 2 minus a half. So I have to write both answers. 3 over 2 plus a half will be 4 over 2, which is just 2. 3 over 2 minus a half will be 2 over 2, which is just 1. So my two solutions for this one will be x equals 2 or 1. Here, use completing the square to solve the quadratic. We'll do this again. And so here, I'm going to subtract 11. That'll give me 3x squared minus 6x equaling to negative 11. And now here, because I have a coefficient that's something other than 1, it's 3. I have to divide by 3. That'll give me x squared. 3x squared divided by 3 is x squared. Negative 6x divided by 3 is negative 2x. And then negative 11 divided by 3 is negative 11 over 3. So here I'm going to add 2 over 2, negative 2 over 2 squared to both sides. And that'll give me x squared minus half x. Now, negative 2 over 2 is just 1. So I'm going to add negative 1 here, squared. Come on. Squared. Squared equals to negative 11 thirds plus negative 1 squared. And this is my perfect square binomial. It becomes this x minus 1 squared. All right. And so negative 1 squared is positive 1. And since we have to add it to negative 11 thirds, we have to have a common denominator. So this negative 1 squared positive 1 is going to be 3 over 3. And then this will still say negative 11 thirds. So let's simplify this. Negative 11 plus 3 is negative 8 over 3. And then we have x minus 1 squared. So here we're going to do the square root. All right, so when I do the square root, I'm going to have x minus 1, but I'm going to have plus or minus the square root of 8 over 3, or negative 8 over 3. So first we're going to deal with the imaginary because we have a negative under there. And so I have my 1, and then we'll go plus or minus I, and then we'll go square root of 8 over the square root of 3. So we've got two things here. we have to simplify square root of 8. And so we'll do that first. So I've got x minus 1 equals plus or minus I. 8 has a perfect square, or isn't a perfect square, but it has a factor that it is. 4 is a perfect square. The square root of 4 is 2. 4 times 2 is 8. So I still have that square root 2 there, so I have to leave the square root of 2 there. And I have the square root of 3 on the bottom. So we're going to rationalize the denominator by multiplying by square root of 3 over square root of 3. Funky one. I'm going to do that. The McCullyism funky one. So I'll have x minus 1 equals plus or minus I 2 square root of 2 over square root of 3. I'm going to multiply that by square root of 3 over square root of 3. All right. And so since square roots are the same as exponents, a to the 1/2, or let's do it this way. Let's do it in general. Let's not use 1/2. A to the x times b to the x is equal to a b to the x. So this becomes x minus 1 equals plus, come on, plus or minus I 2 square root of 6 all over square root of 9. And so here I'm going to add 1 to both sides. I'm going to bring this 1 over and simplify square root of 9. So I'll have x equals 1 plus or minus 2I square root of 6 all over 3. And we can leave it like this. This will be my final answer. I would probably also accept x equals 3 plus or minus 2I square root of 6 all over 3. And I'll let you figure out how I got that and or ask me in class. Well, that's all I got for today, folks. So our today's Marvel fun fact of the day. In the comics, Captain Marvel's cat, actually, it is a flurkin, a space cat, I suppose. It's an alien that looks like a cat. In the comics, it's named Chewie after Chewbacca from Star Wars in Episode 4, New Hope. In the film, it was named Goose after Goose Bradshaw from Top Gun. Both excellent co-pilots. Well, that's all I got for today, folks. Have a good day. Bye.